Okay, let's try that now. So we got Mg3N2, and it's reacting with oxygen to produce MgO and N2. Okay? So I want you guys to see if you can balance it. That's putting those big numbers, the coefficients, okay, in front of the appropriate compounds. Okay? Start with the biggest number. That's our general rule for balancing. Okay? The other thing I'd like you to do, once you've balanced it, write it out in words and tell me what type of reaction this is. So balance, write it out in words, which is basically just naming everything, okay? And what kind of reaction is it? Give you a couple minutes. So let's start with the balancing. Biggest number is 3, and it's on which element?
Magnesium.
On magnesium, okay. So on this side I've got 3 magnesiums, so I'm going to go over here and put a 3 there. That's going to present a problem, don't you think? Because now I have an odd number of oxygens on one side and I've got an even number on the other. Okay, what would be the lowest common multiple between 3 and 2? 6. You're going to have to do that occasionally when you do this. Okay, sometimes you're going to get to exactly that situation and you're going to be like, oh, this isn't going to work. Okay, so what we want to do then is go, let's put a 6 here instead. Okay, now what needs to go here? A 2. Okay, now when I do that, how many nitrogen does that give me?
4.
It gives me 4. Okay, so what needs to go here? 2. Okay, and I've got 6 oxygens here. How many here?
2.
What needs to go here?
3.
Okay, so that one even had a little like block to stumble you on. Okay, that whole, oh wait, this didn't work the first time around. If you run into that problem, doubling it will usually take care of it. Okay, we just have to find the lowest common multiple. You do that all the time in balancing. Okay, so a little tiny bit of math there that you'll have to do in finding the lowest common multiple. All right, the other thing I asked you to do is identify what type it is. We got an element reacting with an ionic compound. What kind is that? Single replacement. So you could just write like SR inside that, single replacement. Then I need to write it out in words, which is just a naming exercise. Okay, this stuff here is magnesium nitride. Okay, what's this stuff? Oxygen. Okay, anybody tempted to write dioxygen there? Even if you're not going to admit to it, I'm going to say good, because you shouldn't. That's how oxygen comes as it comes as a single molecule. It's one of our molecular elements. Okay, that's how oxygen appears as an element. It doesn't get its name changed because it comes as a molecule. That's how oxygen comes. Okay, so we just write oxygen. That's that stuff's name. Okay, then arrows always separate the reactants from the products. Okay, so this goes to magnesium oxide and nitrogen. Okay, so elements don't get prefixes. Okay, that's just how they look when they're an element, right? If I had S8 up there, okay, that's how sulfur is, right? If I had a reaction that had S8 in it, I wouldn't call that octasulfur. It's just sulfur. That's how sulfur comes. So it's a single element, even if it's got a number beside it. It's still just that element's name. Okay? All right. Let's try one more here. Let's go with okay, same 3 things. Balance it, give me a reaction type, and write it out in words. Okay, naming exercise. Okay, let's look at the balancing part. What's my biggest number? 3. but 2 different elements have it. Okay, so does it matter then which one I start with, or should there be a tiebreaker procedure? A lot of the time it doesn't matter, but when it does, it's nice to have the tie-breaking procedure. Okay, so here's what I use as the tiebreaker. Both beryllium and sodium have a 3, but beryllium has a charge of 2. Sodium only has a charge of 1. That generally means beryllium is going to have a bigger effect on the overall balancing numbers in the reaction. In the end, if you started with sodium, it would probably work out. But in the odd chance it doesn't, you'd have to erase everything and then start with beryllium. So that happens sometimes. Okay, let's start with beryllium. I got 3 beryllium, so I'm going to come over here and put a 3 here. Okay, how many sulfur does that give me? 3. Okay, so if I go over here and put a 3 in front of this, how many sulfur does that, or sorry, how many sodium does that give me?
6.
Now you see why I wanted to start with beryllium? Okay, so now I'm going to come back over here and put a 2 here. Now my sodium is also balanced, and so is my phosphorus. That last number fixed the last thing. Always a good sign. If you've done it right, your last number you write in should fix the last 2 things. Okay? So both of those are reasonably tricky. Okay, what type of reaction is this? You bet. 2 ionic compounds producing 2 ionic compounds. Double replacement. Okay, writing it out in words. Okay, sodium sulfide plus beryllium phosphide gives us sodium phosphide and beryllium sulfide. Okay? Each one of those on like a quiz or an assignment would probably be a 3-mark question. I would give you 1 mark for the type. Okay? That's supposed to be a 1. Okay, 1 mark for the type. I would give you 1 mark for balancing it correctly, and I would give you 1 mark for it being written out in words correctly.
When we name it, do we ever need like Roman numerals for like prefixes?
If you had one where Roman numerals were appropriate, they would have to be in there.
Okay.
Absolutely. Prefixes too if you had molecular compounds.
Okay.
All right? Questions on that? Okay. So reactions is the most important thing in the chemistry unit. Okay? Like on your unit exam, it's going to account for somewhere between half and 2/3 of the marks. Okay? Because everything kind of comes back to it. Okay? So it's something you want to practice. Writing reactions, balancing reactions, and even later this week we'll get into predicting reactions. Okay? Those are all skills that you're going to have, and they all require the same thing, practice. Okay? We're going to spend close to 2 weeks on reactions. Okay? So yes, you should still do a little bit of practice at home. Okay? You can use, I'm going to give you a copy of this section of the workbook today, so you'll have those. But you can also, if you want, okay, I tried this out and it worked pretty well. I used the Gemini, the AI for Google, okay, and I said, make up 5 reaction problems that need to be balanced and written out. And it did a pretty good job. And it can spit out a key with the explanation for the answers. And it only had 1 mistake. Okay, so not bad. If you were looking like, oh gee, I did all the ones in Coderre's workbook, don't do that tonight. Okay, please. I want to save some of those for class. Okay, but if you're wanting a little extra practice, there's a perfectly responsible use of AI. Okay, say please. Okay, and I please have this many. Our future machine overlords will remember you were polite when they take over. Okay. All right, well, let's have you guys try. Let's go with the first 3 here. So same thing we were just doing. Okay, written out in words, balance, and write the type. Okay, 3 things for each one of those. Okay, so it's a synthesis reaction, 2 elements combining to form a single compound, and we need to balance starting with the biggest number, that's 3, but on this side, we have 2 hydrogens. So lowest common multiple, 2 and 3 is 6. Okay, what do I need to multiply 3 by to get 6? Okay, and then on this side, 3. Okay, pretty obvious, right? All right, now when I do that, it also gives me 2 nitrogens. Nice. Okay, got 2 over here. Now, you don't necessarily have to write a 1 in here, okay, but I'd like you to get in the habit of doing it. Okay, even though it's not entirely necessary, here's why I say get in the habit of it. If I give you a fill in the blank question for balancing, and you don't write 1s, what do I think? I think it's not done. Yeah, and I don't know whether you just quit in the middle or whether you knew they were all 1s and didn't write the 1s. So I always write 1s, okay? And I would get in the habit of writing 1s. It isn't, in this case, it isn't wrong to write the 1s as a balancing coefficient, just to be clear. Okay? All right, how many people have done number 2? Okay, let's have a look at that one. All right, so in number 2, I've got an element reacting, oh, sorry, I forgot to write this one out in words. Hang on, back up. This would be nitrogen plus hydrogen. Okay, that thing we talked about before. These are molecular elements, so they don't get prefixes. Okay, it's going to give me nitrogen trihydride. Okay, that's a molecular compound because hydrogen is listed second. Okay, so that would be 1 mark for the balancing, 1 mark for the type, and 1 mark for the reaction in words with no mistakes. Okay, second one. I've got an element reacting with an ionic compound, making a new ionic compound, new element. Reaction type? Single replacement, yep. Okay, let's balance. Biggest number is 3. Calcium's a 3. Okay, so I've got 3 calciums over here. I'm going to put a 3 here. When I do that, how many chlorine does that give me? 6. What needs to go in front of chlorine here? 3. Okay, and then I got 2 nitrogens, and I got 2 nitrogens over here. We're good. Okay, so writing this out in words, nitrogen plus calcium chloride gives calcium nitride plus chlorine. Okay, questions on that one? All right, give you a couple more minutes to get number 3 done. If you got number 3 done, go ahead and go up to number 4. So in the third one, I've got a compound that contains carbon and hydrogen, in other words, a hydrocarbon, and it is reacting with oxygen, and the products are water and carbon dioxide. What reaction type would that be? Combustion. That's definitely a combustion reaction. Okay? It is the simplest of the hydrocarbon combustion reactions because that stuff is methane, fart gas. Don't light your farts on fire. Okay? A, they probably won't light on fire. Okay? There's a fair amount of moisture there, okay? But also that'd be dangerous even if they did. Yeah, so don't. Because I always get that question. Would that be like a light them on fire? Technically, yes. Practically, don't. Okay. Just putting it out there. All right, so methane is actually being used in a lot of places as a heating fuel. Okay, they actually capture it, okay, from bovines. Like they can capture, you know, if they got a bunch of animals indoors, they'll actually capture and separate the methane that they produce. Okay, there's also bacteria that produce methane, and it can be captured, and then it can be used to heat homes and things like that. All right, so we are going to write here not methane. We're going to write carbon tetrahydride, okay, and it's reacting with oxygen, and it's going to produce water. Incidentally, water is the one thing you can write the common name for, okay? You don't have to go dihydrogen monoxide or hydrogen monoxide or hydrogen hydroxide, there's a bunch of different ways to write. Just write water. Water is the one common name I'll accept. Okay, plus carbon dioxide. Okay, because it's a combustion reaction, we have to look at our special balancing rules. I'm obviously going to balance in alphabetical order because I'm always supposed to do that. But do I also need the rule of 2? I use the rule of 2 if I have an even number of carbons. How many carbons do I have here? 1. And 1 is not only the loneliest number, it is also an odd number. Okay, so it's got it all bad. All right? So, 1 carbon, I don't need anything in front of it. What goes here? A 1, yeah. So I'll start with a 1, and 1 will go over there. Okay, now I've got how many hydrogens here since I'm going in alphabetical order? I've got 4. Okay, so what needs to go in front of this?
2.
Okay. So now I've got 4 hydrogen atoms. Now I can look at my oxygens. How many oxygen here? 2. How many here? 2. Okay, so what needs to go here? A 2. Now everything's balanced. Okay, so remember, with combustion reactions, they have their own rules. Okay, everything else we can start with the biggest number, but combustion we got to do alphabetically. All right, everybody with me? Toby, you with me? Okay, cool. Last one. What kind of reaction is that? It's a decomposition reaction. Okay, if we're writing that out in words, this is molecular. Most decomposition reactions are, okay, they usually do start with a molecular compound. This would be trinitrogen disulfide. Okay, and that is, here's the trick with decomposition reactions, especially with molecular compounds. They usually produce special elements. Right now, not a big deal, we see them. But when we're predicting the products, we have to remember which ones are special because it'll affect our balancing if we don't. Okay, so this stuff would be nitrogen plus sulfur, just sulfur. That's how sulfur exists as an element. Okay, pretty obvious what to start with here. Okay, which element should I start with? Sulfur. It's by far the biggest number. All right, I've got 8 sulfur on the product side. How many on the reactants? All right, what needs to go here?
4.
Okay, when I do that, it gives me how many nitrogen? Okay, what times 2 is 12?
6.
Okay, and that would be a 1. All right, I think I got 2 more there for you guys to try. 3 more. 3 more there for you to try. Okay, same thing with those 3. So for this one here, I've got an element. In this case, it's chlorine. It's reacting with an ionic compound, sodium iodide. And that is going to produce iodine as an element and sodium chloride, which is an ionic compound. Okay, what kind of reaction is that then? That is a single replacement reaction, right? Okay, now, in this one, I have a tie for the biggest number. And they both have the same charge, so does it matter which one I pick? No, like either one will work. And I'll just start with chlorine because it's first. There's 2 chlorines over here, how many here? Just 1, so what needs to go here?
2.
Okay, when I do that, it gives me 2 sodiums. What needs to go here?
2.
Does that fix my iodides? Yes. 1 and 1. Okay, we're good there. How many people have done the next one? Okay. So on this one here, I have an ionic compound, calcium chloride. It's reacting with another ionic compound, sodium carbonate. Okay, and that is going to form another ionic compound, calcium carbonate, and sodium chloride. double replacement reaction. Okay, now just to point out here, how important is it at this stage to be able to write the names correctly? Very important. The names, all 4 of them, 1 mark. Get 1 wrong, you get nothing. Okay, so you got to be able to get those correct. It's going to be even more challenging when I flip the script here and I give you the reaction in words. Now you've got to write the formulas correctly. And if you don't, will you get the balancing right? I mean, you might make it balanced, but the reaction won't be right. Okay, so this is where we have to be very proficient at writing names and formulas. Okay, we got to balance this thing. What's the biggest number? 2, right. This is the reason I put this reaction up there, right? Because a lot of times we'll just be looking through this, remembering that biggest number rule, and we'll go 3. But there's not 3 carbonates, there's 1 carbonate. Polyatomic ions are often a tripping point for people, okay? Because they see those bigger numbers. Remember, this is a situation where maybe it's better to always have them in brackets, because now you know this is a 1. Okay, so totally up to you there. All right, so biggest number is 2. It's on both sodium and chlorine. They both have 1 as a charge, and they end up together over there. That's going to make this really easy. Okay, so that's a 2, that's a 2. That needs to be a 2. Do I need to change anything else? No, everything else is a 1, right? There's 1 calcium, 1 calcium, 1 carbonate, 1 carbonate. We're good. Okay? Sometimes you get lucky like that. How many people have done the last one? Okay. What kind of reaction is that? It's also a double replacement reaction, but there's one little trick in this one. Actually, 2. So the first stuff, ionic compound, hydrogen chloride, or hydrochloric acid. Okay? It is reacting with potassium hydroxide, also an ionic compound. But potassium hydroxide is it's got a polyatomic ion. This one's an acid. This is a base. Okay. When you mix an acid and a base, what do they do to each other? They neutralize or cancel each other out. Okay. So that's why we get this as a product in every acid-base reaction. What do we call that stuff? Water. Yeah. Okay, this is the way we write water in a replacement reaction. Now there's the weird part. I said replacement reactions only have what kind of compounds in them? Ionic. Water is molecular, but it's here because water's weird. Okay, and in this situation, even though it's not an ionic compound, we write it like it is. Because if I write it this way, it's easy to see where the 2 parts come from. If I write it as H2O, it's a little trickier to track the hydroxide. Okay? So if you've got hydroxide on one side, water on the other, it's usually better to write it as HOH, so you can figure out where the OHs and the H's go. Okay? Toby, did you have a question? Go ahead. Okay, water plus potassium. Okay, so anytime you neutralize an acid, you get water and a salt. Not always the salt, but a salt, some ionic compound. All right? Now, this is obviously, as all neutralization reactions are, a double replacement reaction because they're all ionic. What do I need to do to balance this? Absolutely nothing. Okay? Now I can tell that just by looking at it because there are no what? Yeah, there's no little numbers, right? If there's no little numbers, everything's a 1. Okay? And you're going to run into that. Sometimes you'll even get one that's got little numbers, but it's already balanced. They just happen to work out that way. Okay? So sometimes those throw people off. Like, oh, it feels like I should have to do more here, but you don't. Okay? In this case, everything is already balanced. All right, how are we feeling about that? Okay, so as I was saying, this week we're going to do quite a bit of reaction stuff. Okay, today is focused mostly on I give you the reaction in its formula form, you give me the name, the type, and the balance. Tomorrow we'll move on to I give you the formula form, I give you the word form, You write it in formula form, identify the type and balance. So same idea, but flipping. Okay? And then on Thursday, we'll probably move into, I give you just this much. So what kind of reaction is that? Right. See, you can identify it just from the reactants. You can with all of them because they all start differently. Okay? So if I can identify what type it is, can I look at the pattern and go, all right, I know who's going to end up with who? Okay. In this reaction, who winds up alone? Phosphorus. And I have to remember that phosphorus is special when I do this. Okay, who ends up together? Sulfur and sodium. Who do I write first? Sodium. Okay. Is that an ionic compound? What did I not do with it? What have I not done with that ionic compound? I haven't dropped and swapped it. Okay. Did I just predict what the products would be? Is that really a whole lot different than what we were just doing? Not really. So if you want something to study this week, study the 5 reaction types. Make sure you commit those patterns to memory, because being able to identify the type of reaction from just the reactants is going to be crucial when we get to this, which is Thursday. Okay? Because we're going to need it on Monday when we do our reactions lab. We're going to be predicting the products of the reactions we do, the 7 reactions in our lab. Okay? But like I said, it's not super difficult. If you know the patterns, okay, you're going to be able to predict very quickly. Okay? And they all have a pattern. All right? If I wanted to balance this, what should I balance first? I balance sulfur first, right? Biggest number? Okay, so there's 8 sulfur here. How many over here? 1. Okay, what goes here?
8.
Okay, how many sodium does that give me?
16.
I don't know anything that multiplies by 16. By 3 to give me 16. Is that a problem? A little bit. Okay. Let's try something else then. Let's see if we can't make this work starting with phosphorus. How many phosphorus over there? Okay, so maybe I can go to 4 here and see if that works. If not, I'll just keep trying multiples. Okay, so that gives me 12 of these. Okay, that's not going to work because 12 and 8 don't go together. All right, let's go back to the sulfur. I had 8, but I put an 8 here and it didn't work. Could I put a 16 here instead? Okay, let's try that. Sometimes that happens. That means I need to put what here? Okay, this is about as tricky as they would ever get, just so you know. Okay. All right, now I've got how many sodium there?
32.
32. 1 times 3 gives me 32. Yeah. No, 8. No, 8 doesn't go by 3. Did I mess something up here? I'm starting to feel like I messed something up, but I didn't. Okay, well, let's keep trying. This happens sometimes. Sometimes it gets a little bit tricky. Okay, so we tried 16 there. That didn't work. Okay, 32. No, that didn't work. Oh, if I try 32 over there, that might work. It's big. So now I've got 64, and no, I don't have anything that'll give me that either. Whoa, I picked a tricky one. This is what happens when you make them up off the top of your head. Can I use what? Here? Okay. 3. Okay. 48, so that'll be 16 there, right? And we might be on the right track. Oh, nicely done. Good job, whoever gave me that. Okay. I would probably never give you one like that on the test. Look how long it took me to do it. Okay, so yeah, sometimes you have to go back and forth, right? We can use that to start with the biggest number rule. We still did, we just couldn't get to something that worked, right? Oh wait, no, yeah, that works, yeah. Okay, making sense? Again, that would be absolutely as tricky as it would possibly ever get. And I'm not that cruel, most of the time. Okay, first, before we do anything, I want you guys to take a 5-minute break here. Get up, walk around, talk to each other, then we'll move on to that. Okay, you got 5 more here. All right, we said the best way to get good at this is to practice. We got time to practice. Okay, write those 5 down. Same 3 things. Type, balanced, written out in words. Okay, so I would never give you one like that on a quiz or a test or an assignment or anything that was worth marks because I haven't taught you the prefix for 18. Okay, so we could just say that this is fuel because that's what it is, or I'll just tell you this is octane. That's the active ingredient in gasoline. Okay, so obviously I wouldn't do that on a test because you don't know what the prefixes are, but you can go from there. How many people have done the first one? Can we go over the first one? Okay. So in the first one we have an element, sodium. It's reacting with another element, chlorine. So what kind of reaction is that? Synthesis. Okay, and it is making an ionic compound, sodium chloride. Okay, got to balance it. Biggest number is 2. Only chlorine is out of balance. So what needs to go here? And what needs to go here? Okay. Very good. All right, I'll give you a few more minutes on 2 and 3, then we'll go over those ones, especially since I didn't tell you what that stuff was called. Okay, let's look at number 2 here. So we have our octane. It's reacting with oxygen, and it's producing carbon dioxide and water. Okay, what kind of reaction is this? It's a combustion reaction. All right, as soon as we see combustion, we know we got 2 special rules to consider. Will I need them both? Yes, 8's an even number. Okay, and if there's an even number, I start with a 2. Okay, if I don't do that, this is going to be very difficult. All right, so now I'll balance in alphabetical order. 2 times 8 is how many? 16. All right, now for the hydrogens. 2 times 18 is 36. 18 times 2 is 36. Now I've got both numbers in the products, so I can calculate how many oxygen I have. In the carbon dioxide, I have 16 times 2, that's 32 oxygens, and I have 18 more oxygens here in the water. Pretty sure that 32 plus 18 is 50. Okay, what times 2 will give me 50? Right. 25 goes there. I find people struggle with the even numbered ones more than the odd numbered ones because sometimes they just forget to put that 2 in and then things just don't work out. Okay, if there's an even number of carbons, start your balancing with a 2. Okay, then from there it will work out. Okay, Riker, you're giving me a sideways look. What's wrong? Make sense? Sorry, you're kind of going. Just want to make sure. Okay, how many people have done 3? Okay, let's have a look at 3 here. So for number 3, I've got an element, calcium, and it's reacting with an ionic compound, lithium nitrate, nitride, not nitrate, nitride. Okay, and that is going to form a different ionic compound, calcium nitride, and another element, lithium. Okay, what pattern is that? Or what reaction pattern, sorry, is that? Single replacement. Okay, biggest number is 3, but there's a tie. Lithium and calcium, which one should I start with? Calcium, bigger charge. Okay, so I'm going to take this 3, I'm going to put it here. All right, well, that doesn't really do much, okay? For my lithiums, though, I don't want to go 3 and 3 because nitrogen is part of that compound, okay? So what I'm going to do is I'm actually going to do nitrogen first because I can see what's going to happen here, okay, looking ahead. So how many nitrogen here? 2. So I'm going to put a 2 there. Now how many lithium does that give me? 6. What needs to go here? Okay, and that's a 1. Okay, sometimes you got to kind of look ahead. That's why I didn't want to do lithium first. I knew that was what was going to happen. Okay, and as you get better at this, you'll be able to pick those out. All right, I'll give you a few more minutes and we'll go over 4 and 5. All right, so for number 4 here, okay, I've got just a molecular compound as the reactant. That molecular compound is dinitrogen trifluoride. Okay, what's the only kind of reaction that starts with a single reactant? Decomposition. Yeah. Now the trick with decomposition reactions is they often form special elements, which we see here. Not so crucial right now that you see them there, but crucial when you're predicting. You have to remember that those are a 2 or a 4 or an 8 as the case may be. All right, so that stuff makes nitrogen and fluorine. Okay, biggest number is 3. So how do I balance fluorine and fluorine? Right, lowest common multiple, right, is 6. So a 2 on this side and a 3 on this side. Putting that 2 there gives me how many nitrogen? Okay, so what needs to go here? All right, and then we're good. Okay, last one. I got an ionic compound, beryllium cyanide, okay, plus silver carbonate, another ionic compound. And that is going to make another ionic compound, silver cyanide, plus another ionic compound, beryllium carbonates. What's the only reaction type that has all ionic compounds? Double replacements. Okay. Biggest number here? 2. Yeah. Okay, there's 2 cyanides and there's 2 silvers. And they both end up together on this side. So what needs to go in front of this?
2.
Okay, do I need to do anything else? No, everything else is going to be a 1, right? There's 1 carbonate, 1 carbonate, 1 beryllium, 1 beryllium. Everything else is a 1. Okay. How are we feeling about that? It's very patterned, right? Like once you kind of learn this is the step I do first and then this step, it kind of just comes to you. But as with anything, it just takes some practice. All right? Okay. Some reminders here. Okay, we still have time left, but I want to talk about some reminders. Lab reports due tomorrow, 8:30 a.m. Okay, they got to be in by 8:30 a.m. tomorrow. So make sure those are submitted on Google Classroom. I will be here for a short period of time after school, okay, if you want to have them looked over then. Okay. And then tomorrow we'll go over the flip side of this. I might even put one up just to see how we do with it, where I give you the words and you put the formula reaction, name, or sorry, balance, and identify type. And then Wednesday, probably a little bit of both, just a lot of practice. Guys, this week, ask questions. If there's something you're not getting, you're repeatedly getting things wrong, this is the week to ask, right? We're practicing, we're learning these skills, okay? Ask me to come over to your desk and I'll give you a hand, okay? There's zero shame in doing that. It's really smart to do that. You're not bothering me at all by asking for help. That's what I want, okay? And then, like I said, Thursday, we'll probably move into predicting. Friday will be your quiz. Practice quizzes 7, 8, and 9. At this point, the only thing that's we haven't done is the flip side, where I give you the words and you write it out in formula form, but like the principles are still the same. So you could probably do parts of those 3 quizzes already if you were looking to just do parts of something. Okay? And then obviously next week we'll do another lab. Okay? On Thursday, at the beginning of class, we will go over the lab report. Right? You're handing it in on Wednesday. I'll have it turn around and back to you, and we'll go through it as a class so you can see, okay, I got marks here, I didn't get marks here, as some feedback for your next lab. All right. Oh yeah, okay. But before we try those, actually, this is what I want to do instead. Let's try the flip side here. Sodium. Otherwise, I break the rules, and I created an element, sodium nitrate. Okay, so with this one, write it out in its formula form. Identify the type and balance. Okay? Things to be mindful of. Swapping and dropping ionic compounds. Looking out for special elements. Okay, so just in the interest of getting this done before the bell goes. Okay, sodium oxide. Na with O, that's a -2, that's a +1. Na2O. Plus nitrogen. 2, right, gotta watch out for those special elements. Okay, is gonna make oxygen. 2. Plus sodium nitride. Na with nitrogen, that's a -3, that's a +1. Na3N, okay? Biggest number is 2, okay? And it is on both sodiums, so, biggest number is 3, okay? And it is on the sodium, so let's balance that first. Lowest common multiple of 2 and 3? 6, okay, so I need a 3 here. Ooh, that's gonna be a problem, isn't it? Okay, so I can't have 3, but could I have double that? Okay, let's try that. Okay, let's put a 6 here instead. All right, what needs to go here? 4. Okay, now I've got 12 sodiums on both sides. All right, and I've got 6 oxygens. What needs to go here? Okay, and I've got 4 nitrogens. What needs to go here? Okay, what kind of reaction is it? Single replacement. Okay, so it is a little bit trickier going the other way because you got lots of things to check. Special elements, swaps and drops. Okay, good job today, guys. Right. Remember, have those lab reports in by 8:30 a.m. tomorrow.